dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Warahmatullahi wabarakatuh. So welcome from Forest. This is our third class e-learning program, Amano Schools. So this is a chemistry lesson. Me, teacher Abdurrahman Musa. So we want to continue our lesson. So our chapter was organic chemistry. So we came across the introduction of organic chemistry. For today, we want to start what we call functional group and homologous series. So what does mean functional group or functional groups? So functional group is divided as a special part of the atoms. So consider here functional group. So functional group is a special part of atoms. It can be atoms or bonds that is largely responsible for the chemical properties of the parent molecule This is very important, this functional group. So functional group we can define again. A group is of atoms or bonds which is responsible the chemical properties. When I say chemical properties, means the reactions of the family. So chemical properties and reactions is the same. So it's a special part of atoms or bonds which determine the chemical properties of that particular family. For example, so it gives the compound some distinctive predictable properties. Consider here. For example, alcohols. Alcohol is a family. So the functional group of alcohols is hydroxide. So all alcohol should contain OH group. So this OH group is the functional group of alcohols. What about alkanes? They contain carbon, double bond carbon. This is the functional group of alkanes. What about carboxylic acids? They contain what? COOH. What about amines? They contain what? NH2. What about halogens? They contain what? That one. Okay. So this is what we call a functional group. So most of the families, they contain a special part which is responsible the chemical properties of that particular family. This is called what? Functional group. It can be atoms, it can be bonds. Okay. Consider here, we have an example. So alkanes, they contain carbon, double bond carbon. So this is an example. So this is the functional group. That double bond is the functional group. Alkynes is another family. They contain triple bond. So triple bond is the functional group of alkynes. OH or hydroxide group is the functional group of what? Alcohols. So aldehydes, they should contain carbonyl group, and here you have hydrogen. So this part is called what? The functional group. So this part is called what? The functional group of aldehydes. Ketones, they contain carbon double bond. You see, carbon double bond, carbonyl group. Here is R and here is R. Okay, I want to mention that one again. So you see this part this is R, or you can put here carbon. Here is carbon, and here is carbon. So carboxylic acids, you see this is alkene, alkyne, alcohols, aldehydes, and ketones. So these are not the same. This contains carbonyl group, hydrogen, carbon. What about ketones? They contain carbonyl group, carbon. What about carboxylic acids? They contain COOH. Here you can write. No, sorry. So so this is a bond. Again, here is a bond. Okay. So I can't write on this one. So ester. This is the functional group of ester. So most of the families, they have what? A functional group. And this functional group, this part is very important. it is responsible for the reaction of the family. For example, alkanes and alkynes, they do a reaction called addition. So they undergo addition reaction because of the double bond and triple bond. Alcohols, they do what we call dehydration because of the OH group. What about aldehydes? Aldehydes, we can oxidize aldehydes to carboxylic acids because of what? This functional group. Okay. This is another term what we call homologous series. So what does it mean, homologous series? It's a series. It is a trend, say list of organic molecules with the same functional group and have a similar both physical and chemical properties. So homologous series means what? It is like a trend. It is like a list, say a sequences of molecules, but they have what? They have a same functional group. They contain the same functional group. Again, when they contain the same functional group, they behave in a similar way. Physical properties and chemical properties the same or the similar. Consider this one. Here you have alcohols. Here we have alcohols. Alcohols, this is carbon number 1, 2, 3, 4. This is the list of alcohols. So this kind of list is called homologous series. Same series, same trends. They behave in a similar way. You see, we said homologous series is a series of organic molecules with the same functional group. They have the same functional group. Consider this red one. All alcohols contain hydroxide group. This, you see, they have the same functional group and have a similar both physical and chemical properties. If they contain same functional group, they behave in a similar way. So this kind of family, this kind of list is called homologous series. It's called what? Homologous series. If you consider again, this is methanol, ethanol. Methanol and ethanol. They have a difference of what? 1 carbon each and 2 hydrogens. So if you can see that each formula has 1 carbon more and 2 more hydrogen atoms than the previous one. For example, methanol and ethanol, the difference is what? CH2, what we call methylene group. So each family which looks like this family is called homologous series. So this is alcohol. So alcohol is an example. What about alkenes? They are same principle. What about carboxylic acids, aldehydes, ketones? So they behave in a similar way. So this is called alkanes. So alkane is a various family we want to learn. So we want to discuss. So alkanes are divided what? We can divide alkanes as what we call, number 1, they are saturated. Again, they are hydrocarbons. So I can say alkanes are saturated hydrocarbons. But there are other families which are hydrocarbons, again saturated, like cycloalkanes. But they are different from what? The formula. So alkanes are saturated hydrocarbons with the formula, say CnH2n plus 2. So this is the definition of alkanes. That's the definition of what? Alkanes. So alkanes, number 1, they are saturated, which means they are full of hydrogen. So every possible location is attached by what? Hydrogen. So we came across the term saturatedness. So they contain single bond between all atoms. With a formula, they have this formula. They can fit this formula. First 4 alkanes are methane, ethane, propane, and butane. So with Lewis symbol, so the structure of Lewis is here. This is methane, ethane, propane, butane. Consider this one. They contain more hydrogen. They are saturated. Every possible location is attached by hydrogen. That's why we are calling alkanes as saturated. Hydrocarbons, they contain only carbon and hydrogen. We don't have the number of atoms. This is hydrogen, this is carbon. This is hydrogen, this is carbon. So they contain only carbon and hydrogen. So they are hydrocarbons. Again, they contain single bonds between all atoms. That is saturatedness. They fit this general formula. They fit this general formula. Okay. pass this number. For example, if you pass this number, this is 4, carbon number 4. Next to that number is carbon number. So pass this number of carbons. So the N is the suffix. So suffix is this one. So consider this part, the N part. Ane. So the suffix of alkanes is ane, A-N-E. So this suffix is retaining. It's supposed to be constant. And the number of prefixes. So this is the prefix: mesa, isa, propa, buta, penta, hexa, hepta, octa. So this is prefixes. So benta, hexa, hepta, octa, nona, deca, undeca, dodeca. So we can continue. Okay, here we have a table. So this table indicates you IUPAC names. IUPAC names means what? International Union Pure and Applied Chemistry names. First 10 of alkanes. First 10 of what? Alkanes from mesa to deca. From mesa to deca. So carbon number 1 up to 10. So from metha to deca. Methane up to decane. So this is the molecular formula. We came across the molecular formula. So it is a very concise formula. It's a very concise formula. So this molecular formula, this kind of formula is called a structural formula. Again, condensed structural formula. Yeah, if we draw all the bonds, we can call displayed formula. So this is a structural formula. Again, it is a condensed structural formula. So you can consider this one. Okay. So there is what we call alkyl group. When we are discussing alkanes, there is another group called alkyl. There is another group called alkyl. So what is the difference between alkane and alkyl? Alkane and alkyl, they are always similar. You see, alkyl group is, if hydrogen is removed from an alkane, it can be used in an substituent functional group called alkyl group. So alkane and alkyls are derivatives of alkanes. Alkyls are derivatives of alkanes. For example, this is alkane. For example, this is alkane. This is alkane. This is alkane. Again, this is alkyl. This is alkyl. If you remove a single hydrogen, if you remove hydrogen from an alkane, it will become alkyl. It will become alkyl. You see, the general formula of alkanes is what? This is N, 2N plus 2, 2N plus 2. What about the general formula of alkyl? It is like N, 2N plus 1, plus 1, plus 1. So this is plus 2. This is plus 2, and this is plus 1. You see, the suffix of alkane is ane. The suffix of alkane is ane. The suffix of alkyl is YL. YL. Are we together? YL. Okay. So this is a natural family, but this is a derivatives. These are derivatives. So, for example, if number 1 of alkane is methane, what about here? It's supposed to be methyl. It's supposed to be methyl. You see the suffix ane, YL. What is the general formula of this one? The general formula of this one is CH4. The general formula of this one is what? CH4. What is the general formula of this one? It's supposed to be CH3. CH3. Because of this will fit this general formula, and this will fit this general formula. So this is called alkyl group or R group. So they are always substituent. They are always substituent, branched side chains. So methane becomes methyl group, ethane becomes ethyl group, etc. Propane becomes propyl, butane butyl, pentane bentyl. So alkane derivatives can be formed by substituent an alkyl group for one or more hydrogen atoms. So one hydrogen atom is removed from an alkane molecule, it will become alkyl. It will become an alkyl. So consider here, this is methyl group and this is ethyl group. This is ethyl group. Okay. Okay, my student is, this is the physical properties of alkanes. Alkanes are found in oil and natural gas. Where can we get alkanes? From the crude oil. That's number one. The longer the chain, the higher the boiling point. The longer the chain, the higher the boiling point. For example, if we increase the chain, the number of carbons, the melting point and boiling point also increases. This is property number two. The density depends on molecular mass. The longer the chain, the higher the boiling point. We can say the longer the chain, the higher the density. It's the same principle. For example, they have a density around 0.6 up to 0.7. So they have a lower density than. So my friend, my student is, because of time, we're supposed to stop here. So thank you very much.